Okay, so you've selected your material, and the next thing to do is to think about how you're going to manufacture it. And we touched on this in the lectures also, where your options are, things like blending or, making a hydrogel or maybe it's an implant with a coating, or you have quite a lot of options to choose from in this space. But for us, and this example, we're using silk and we're going to use electro spinning. So the process steps for that are pretty straightforward. So we've just, in the last segment, we've finished turning our silk cocoons, we've been purifying them, we've got them into solution, and so now they're ready to be injected into the electro spinner. So we use a syringe to carry the liquid silk. The job of the syringe pump is to deliver it at a constant rate. The rate of delivery is one of the process parameters. So delivering the liquid at a faster or slower rate changes our end product, which I'll get to. So that part's really important. It travels through from the syringe through some tubing to what they call the spinneret. So it's the silver nozzle with the needle, and that's the kind of area of the electrospinner that does all the work. So we apply a positive voltage to that metal spinneret, and so the solution's coming out of it, and then there's this 20,000 volt charge applied to the tip, and then at the collector end, there's a negative charge applied, so there's this like potential difference traveling from the tip of the syringe to the collector, and so that potential difference draws the fibers out, and they fly over that gap. So fine microfibers, and they're kind of hard to see in the film, kind of be like fairy floss, and then they're collected over time onto the mandrel in this case. So they're wound around into a conduit, but just as easily you can put a flat collector there and you can make sheets or other different shaped collectors or multiple spinnerets. Like there's ways to change that to lead to different products, but in the simple form and in the form that we're demonstrating here, syringe into the spinneret, the potential difference, the charge does all the work, and then it drags the fibers across the space onto the collector. Now, the beauty of this technique is that you've got really fine control over your end product. So you can see in cross-section we get white graphs that are a collection of the silk fibers. And then looking at cross-section, you can see it's quite porous, for want of a better word. And then kind of zooming in on either the inside, which is the luminol, or the outside, which is the mural, you can see that the construction is literally kind of randomly oriented fine fibers that kind of lay over each other and are interconnected to create the pores. Now, the process parameters that I'm talking about, so I touched on syringe speed, but it's also, silk concentration or charge or a distance between the spinneret and the collector. All of those things have subtle effects on these on the final product parameters. So we can use those things to change porosity, to change fiber thickness, to change graft wall thickness, actually. And so, looking at some of the outputs that are possible then, by changing the volume in this next slide, you can see wall thickness kind of going up and up and up as we deliver more volume. And then the overall porosity is kind of preserved, which you can see in the bottom photos. So for this application, electrospinning is a really useful one because it gives us this really precise control. So compared to casting or making a gel, that's a lot more imprecise. Because this is a natural material, we can't do extrusion or the commercial manufacturing processes that I've touched on with you. So we're kind of boxed into needing a manufacturing process that's compatible with this natural material. Now, the other thing you can do with electrospinning that's really cool is, you can make blends and you can make layers. So in this example, we just have straight silk and a single layer, but it's really easy then to get another solution, spin another layer, or to co-mix, silk with another material in the solution part, and then to generate a material that's a hybrid of the two. That's why it's a strong technique. So anyway, the finished product here is electrospun conduits. We can control the diameter, we control the wall thickness, we can control the length. So it's a really versatile and good technique for this unmet need.